Sorry for the delay. At least now I know how to travel in Hamburg via taxi better than the taxi drivers. So, welcome everyone. My name is Ihor Dvoretskyi. I'm a developer advocate at the Cloud Native Computing Foundation. And today I'll highlight the few milestones of the Kubernetes project. So this year, we're celebrating the big anniversary of Kubernetes project. We're celebrating the 5 years since the Kubernetes project establishment. So before we proceed, I'd like to remind you about the story behind Kubernetes and behind the technologies that preceded this, the Kubernetes technology before. This is probably the well-known slide. It was presented at multiple cloud native conferences, but I'd like to remind you right now about which technologies have been developed in this world and which technologies have been adopted in this world before Kubernetes was widely adopted and widely used, and which technologies have been the technologies that were widely used, for example, like 15 or 10 years ago. So we started with the non-virtualized hardware long time ago. It was the pretty basic way of developing and deploying your applications and running infrastructure with just the bare metal servers somewhere in the data center. But it was not so flexible way of managing your infrastructure. So the virtualized technology has been developed some time ago, and with the virtualized technologies, with the ability to virtualize your operating system and with the ability to virtualize your hardware, people received the ability to be more flexible with managing storage, with managing networks, with managing the compute power. But it was also not so flexible as it could be in terms of managing the infrastructure itself, comparing to the public clouds, for example. So the public clouds were presented like around, the public cloud concept was presented around 15 years ago. And for example, the AWS was one of the pioneers here in this era with the technologies that allowed you to run your infrastructure as a service, just to click and run the virtual machine or network or storage, or even to provision that via the stable APIs and so on, just to like run some kind of application that will interact with your infrastructure as a service. But it was still about the infrastructure. It was not about the applications. And if you are for example, the application developer, and you don't want to care about applications, you don't want to care about infrastructure. The way to interact with that was to move a bit higher on the from the abstract standpoint to, for example, PaaS. So PaaS was the platform as a service. PaaS is a platform as a service concept with Heroku, which was one of the pioneers in this era, and it allowed you to simply run your code somewhere, and you don't care about the infrastructure itself. There were also the different technologies like OpenStack and Cloud Foundry that were developed also like some time ago, and they've been developed as the alternatives to the commercial products like AWS and Heroku and many others. But it still was not that exact way. How can you easily manage, park, and operate your applications? And Docker was the real pioneer here. Docker as a technology. So Docker allowed you to easily bundle some pieces of your software into the single piece, ship it anywhere, run it on any kind of machine, like on your laptop, on the public cloud, on the private cloud, like basically anywhere where Docker could be run. And today, Docker could be easily run on almost any Linux distribution. But Docker had like a few pain points, and the biggest one was that Docker was not so easily scalable as is. So Docker is mostly the container runtime with some networking and storage abilities, but it didn't allow you to run your applications on a higher scale, like with 1,000 nodes, with 100 nodes on any kind of infrastructure, on the infrastructure that is being provisioned across the globe, for example, in the data centers in Japan, Europe, and North America, and so on. So at that point of time, the different technologies that were complementary to Docker and were complementary to the different infrastructure technologies were developed, like Mesos, like Docker Swarm, and Kubernetes. So these technologies allowed you to run your applications, run your containerized applications on basically any kind of infrastructure with Docker and in the future with the different containerized technologies to achieve the goal of running them on the higher scale on like any kind of infrastructure, any kind of environment. So that's just a brief story that you may have heard multiple times at different conferences and different events during the last 5 years. So again, like coming back to the beginning of Kubernetes. So Kubernetes story began with the first commit 5 years ago by Joe Beda, one of the co-founders of Kubernetes. And 5 years ago, probably not so many people knew about Kubernetes, and there were not so many people who were using Kubernetes so actively as we are using today. So in 2014, Kubernetes was like pretty raw technology. It was like alpha kind of software that was not so widely adopted, but it had like some bright future. Kubernetes was originally developed by Google, deeply inspired by Google's internal system called Borg, that was that is the Google's internal system for running their infrastructure within containers. So if you don't know, like basically everything that Google runs is run within the containers, and their system that they're using for this is called Borg. So Kubernetes was deeply inspired by Borg, but Kubernetes was targeted for the outer market. For it could be used by anyone, not just by someone who works within Google. So the next year after that, in 2015, the Kubernetes 1.0 was released. So Kubernetes 1.0 was the first big and notable milestone of this technology. Releasing the 1.0 version of the software means that this is the first and major step of this technology moving forward. And at that point of time, 4 years ago, Kubernetes was much more widely adopted than 5 years ago, but still far away from the current state. So with the version 1.0, the Kubernetes was defined as a stable base, but it's still haven't had so many features and so huge ecosystem as it has today. And speaking about the ecosystem, another big organization was established. It was the Cloud Native Computing Foundation. So Kubernetes itself, again, as I mentioned before, it was the open source project developed by Google and open sourced by Google. But it targeted the whole market, the whole world. And the different companies could be interested in contributing there. The different companies could be interested in consuming that, in consuming this technology, not only as a part of some commercial offering by some company. So the Cloud Native Computing Foundation was established with Kubernetes as the first and seeding project. And the goal of, and the reason of establishing the foundation was mostly because that Kubernetes is not the silver bullet, and it's not the single solution that can solve all your needs, even in the cloud native space, but it's the technology that can enable the development of the ecosystem. And with the foundation and with the whole ecosystem, you can easily use different technologies that are not definitely the part of Kubernetes itself, but they are complementary to this technology. And also at that time, the first KubeCon, the community event at that point, the purely community event driven by the community itself has happened. And the next year, the Cloud Native Con was this event was called the KubeCon Cloud Native Con as the bundle of two big events that are covering the cloud native ecosystem in general, not only Kubernetes. So again, like speaking about the next year, in 2016, CNCF bootstrapped the initiative that was later called the Kubernetes Service Provider, Kubernetes Certified Service Provider. At that point of time, it was the initiative that was targeting the creation of the conformance tests and defining the concept of the conformance distribution of Kubernetes. So the goal of this initiative was to allow people to understand that any kind of application that you are running on Kubernetes, on any kind of Kubernetes platform that is called certified, can be easily run on a different platform, which is also called certified. So for example, you're running your application locally on your laptop with Kubernetes on Minikube. And if Minikube is the certified platform, and if it's the conformant platform, it will be you can ensure that this application could be easily run on the similar platform somewhere on the public cloud, which can be also called the certified one. So the goal of this initiative was to enable the uniformity between the different cloud providers and the different on-premise or public cloud and private cloud platforms, with the goal for the users just to care about the applications, not to care about the underlying level and even challenging with some difficulties between migrating the application from one platform to another. So the next year, in 2017, the Kubernetes path was mostly towards the stability and feature-rich and feature enablement. So on this slide, you may see one of the titles of one of the releases that one of the Kubernetes releases that was put to the world in that year. It was Kubernetes 1.8, and it was mostly focused on the security, on the workloads enablement, and on the feature dev. So when we're speaking about the feature dev, we are speaking not only about the number of features that are added to this release, but we don't care about the quality of this feature if we are just speaking about numbers. The feature dev means that we can focus on less features, but we could be focused on their higher quality. So at the beginning, like at the first days of Kubernetes, the first few years of Kubernetes development, there were so many features and so many well-known technologies that are currently well-known technologies that were at that point of time in alpha beta stage. So they were not actively used, and they could not be recommended to be used in the, for example, in production systems. But with the enablement of that features and with stabilizing them, Kubernetes community was focused on creating Kubernetes as more enterprise-focused platform, as well as enabling the security features, for example. Because, for example, if you're using the raw Kubernetes somewhere on the public cloud, you can also use that. You can also use some third-party technologies or the technologies that are bundled into that public cloud provider. But if you are, for example, using that for the high scale application at the different platforms at a different scale, again, like worldwide, you probably would be interested in having the security features bundled into Kubernetes itself. So you should not care with the different configurations for the different platforms. You care about the configuration of Kubernetes itself. And that was one of the biggest and major milestones when the well-known enterprise companies around the globe started adopting Kubernetes. Speaking about the workloads, it was also the year of the big milestones and big challenges. For example, at that point of time, the Windows Server containers were started being supported within Kubernetes. So, like today, this feature is called as a stable, but a few years ago, it was an alpha feature, pretty raw feature, and basically, so many people didn't understand even why do you need to run some kind of Windows applications within Kubernetes. But it was also another big point within the Kubernetes ecosystem, because you could easily run the applications that were developed, for example, for the from the legacy years, from the old years of the application development. You can easily run them on Kubernetes itself, even these days. Even the old applications, even the old designed applications from the 90s, you can also run in Kubernetes today. So the next year in 2018, Kubernetes also moved to the gradated stage within CNCF. So at CNCF, we have a few stages of the project maturity. The pretty basic one is the sandbox, where the absolutely new projects and not so well known are currently hosted. The incubation is the middle tier of the CNCF project ecosystem, where the projects are pretty well known, they are pretty widely adopted, but they are not yet clarified as the widely adopted and as those projects that could be run by anybody, anywhere. And the next tier is the gradated stage. Being a gradated within CNCF means that it's a mature technology. It's a well-known technology that almost everybody knows these days. And Kubernetes was the first technology that moved to the gradated stage last March in 2018 within CNCF. So what do we have today here? Today, Kubernetes enabled the huge ecosystem of the different projects, and you can easily read none of them here on this slide. So for easy consumption of this slide, we have the website on l.cncf.io, but this slide highlights how many technologies were adopted within the cloud-native ecosystem. Not all of them are being actively used with Kubernetes, for example, or not all of them can be compatible with Kubernetes at all. But Kubernetes is exactly that technology that bootstrapped the cloud-native ecosystem as is, and the cloud-native ecosystem is exactly that era of the today's knowledge, where people may consume the huge variety of technologies. Also, Kubernetes is one of the sort of highest velocity projects. So Kubernetes Community is well known for is the well-known friendly community where so many new contributors are coming, and there are like so many contributions happening within the Kubernetes community. And on this slide, you may notice that Kubernetes is one of the few projects in the world that have so huge contributor velocity. Also on this slide, you may notice how Kubernetes is widely searched at Google comparing to the different technologies like OpenStack or Mesos or Docker Swarm. So these days, you may notice that there are way more Google searches looking for Kubernetes compared to the previous years and comparing to the different technologies. And Kubernetes is an industry winner. So CNCF conducted a survey at the end of last year, and we figured out that Kubernetes is one of the most widely adopted technologies within the cloud-native world, and is one of the most adopted technologies to manage your containerized infrastructure and to manage your containerized applications, even comparing to different systems in this era. The cloud-native and the Kubernetes community also has the huge number of programs which are not only about the technology themselves, but mostly about people. So, for example, we have the CNCF Ambassadors program within CNCF, where we have so many ambassadors from the community that are mostly focused on Kubernetes and the different technologies. And currently, we have a bit less than 100 ambassadors within CNCF, and we have more than 50 companies represented from almost 20 countries around the globe. But also, we have the CNCF Meetups program, where we are covering almost the whole globe with a bit less than 200 meetup groups and a bit less than 50 countries represented. So this all for me. Thank you for your time, and hope you'll enjoy the conference.